Imagine a cookie store made a sale. The worker would then take one of these pieces of cardboard and fold it up to make an open top box that they would then place the cookies in before they put on the lid. We want to find the dimensions of this open top box. But where do we start? First of all, we know that this side length is 32 centimeters and this side length is 28 centimeters, while the total volume of the open top box is 1,920 cubic centimeters. Taking a look at the piece of cardboard, we can see that 4 equally sized squares are cut out from the corners of this piece of cardboard, so that the sides can be folded up to create the box. This means that the internal side lengths of the box are not 32 and 28 centimeters. But what are they? Well, taking a look at each of the cutout segments from the box, we can see that each of them are equal length. And since this length is unknown, we can assign it as the variable x. And since all of these lengths are the same, every single side is x. So now, if we were to determine this side length without these two flaps on the left and right, what would it be? 32 minus 2x. Because the entire length is 32 centimeters, but we're taking away 2 x measurements from the left and right flaps. This gives us one of the two side lengths. We can do the same for the side length with 28 centimeters. And we can make it 28 minus 2x, because the entire length is 28 centimeters, but we're taking out the 2 flaps on the top and bottom that are each x. What about on the other side of the equal sign? It should be 1,920, as all of our side lengths multiplied together should give us this volume. But that's the thing. What about this equation tells us that we're solving for volume? Well, we only have 2 lengths, or rather a length and a width. And we know that length times width is equal to area, or centimeters squared. We're looking for centimeters cubed, which is volume, or length times width times height. What is the height of this box? Well, let's go back to our diagrams. Remember how we assigned the length of each of these flaps as x, and how when we fold up each of the flaps, they make the walls of the open top box. Since the flaps are x centimeters long, then the walls should be x centimeters high. And so our height is x. We wouldn't write x plus 0 because just x is nicer. Now our equation is somewhat complete. We have all of our 3 length, width, and heights equaling our total volume. But now what we're going to want to do is solve for x in terms of the volume, so that we can find the possible dimensions of this open top box. First, what we can do is move this volume to the other side of the equation to add it in with the rest of our variables. We're also going to FOIL and distribute this bracket into this bracket. So this will equal x times 32 times 28, which is 896, then 32 minus 2x, so we subtract 64x, and then negative 2 times 28 gives us negative 56x, and then negative 2x times negative 2x gives us plus 4x squared. Close bracket minus 1,920. Now we want to distribute this x into this bracket. So this makes it equal to 896x, and then combining like terms, negative 64x minus 56x times x gives us negative 120x squared plus 4x cubed minus 1,920, which can be rewritten as 4x cubed minus 120x squared plus 896x minus 1,920. Next we can do is divide the whole equation by 4 to give us 4 times x cubed minus 30x squared plus 224x minus 480. Next, we're going to want to use the rational zero theorem that can help us find all of the possible factors of this equation, or in other words, the possible values of x. We assign the last term, negative 480, as p and the first term as q, and our possible factors equal the factors of p divided by the factors of q. Our q value, x cubed, technically has a coefficient of 1, and the factors of 1 are just positive and negative 1. So that means our possible factors are the factors of 480 divided by positive or negative 1. So that means our possible factors will be positive or negative 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 16, 20, 24, 30, 32, 40, 48, 60, 80, 96, 120, 160, 240, or 480. Now, this is a ton of possible factors, considering that any of these positive or negative can possibly work, meaning that when we plug it into the equation, we get 0. A good tip: most of the time, the first few factors and the greater half are not factors, so it's better to start off with the early to mid factors. With that, let's start by plugging in 6. By plugging in 6, we make it 6 cubed minus 30 times 6 squared plus 224 times 6 minus 480. Plugging in 6 gives us 0, so x minus 6 is a factor, because when we put it into a bracket, the sign changes. Next, we're going to use synthetic division to see what the equation would look like when we factor out x minus 6. So without looking at the x's, the values of this equation are 1, negative 30, 224, and negative 480. First, we're going to bring this 1 down, then multiply it by 6. And now negative 30 plus 6 gives us negative 24. Negative 24 times 6 is negative 144. 224 minus 144 gives us 80. 80 times 6 is 480. And negative 480 plus 480 gives us 0. Showing that there's no remainder, so our new equation is f of x equals x minus 6 times x squared, because it is 1 degree less when we factor out the x minus 6, minus 24x plus 80. Now looking at this, we can either use the quadratic formula to find the last two zeros, or an easier way, we can use the box method. But this only works if there are no decimals as factors. But it's easier and you should use it whenever you can. For the box method, basically we want to know what two numbers multiply to get 80 but add together to get negative 24. So we set up our boxes, and x times x is x squared, and off the top of my head, 20 times 4 gives us 80. Now what we're going to want to do is multiply diagonally. So we're going to do x times 4 gives us 4x, and x times 20 gives us 20x. Adding those two together gives us 24x, not negative 24x. A simple fix would be making both of these negative, as negative 20 times negative 4 still gives us 80, but now, when we multiply diagonally, we get negative 4x minus 20x to give us negative 24x. Now our new equation is f at x equals x minus 6 times x minus 20 times x plus 4. Where we get these brackets is we take these side-by-side boxes and put them in brackets. And now what we can do with this is we can take out all of the numbers from the bracket, x equals 6, x equals 20, and x equals 4, meaning that our possible values of x are 4, 6, and 20. Now, from here, we can check if these values of x give us the correct volume. Taking a look at our original formula, 1920 equals x times 32 minus 2x times 28 minus 2x, we can make 1920 f of x. Let's start by doing f at 4, which is one of the possible values of x. This equals 4 times 32 minus 2 times 4 times 28 minus 2 times 4. From here, this equals 4 times negative 2 times 4, which is negative 8. 32 minus 8 is 24 times negative 2 times 4, which is again negative 8, and 28 minus 8 is 20. Now we have a length, a width, and a height. And plugging this into our calculator, multiplying the three together gives us 1920, meaning that three of the possible dimensions are 4 centimeters by 20 centimeters by 24 centimeters. But this is just one of the possibilities. We still have two left. What if we try f of 6? This equals 6 times 32 minus 2 times 6 times 28 minus 2 times 6, which equals 6 times negative 2 times 6, which is negative 12. 32 minus 12 is 20 times 2 times negative 6 is again negative 12. 28 minus 12 is 16. Now we have another set of length, width, and heights, and multiplying these three together again gives us 1920, meaning that another set of possible lengths for this box is 6 centimeters by 16 centimeters by 20 centimeters. But what about a third possibility, 20? Well, I could already see that this is actually not going to work. But let me show it in the equation. F of 20 equals 20 times 32 minus 2 times 20 times 28 minus 2 times 20. This equals 20 times negative 2 times 20 which equals negative 40. 32 minus 40 is negative 8 times negative 2 times 20, which is negative 40. 28 minus 40 is negative 12. And when we multiply these three together, we indeed get 1,920, meaning that mathematically this answer is correct. But in real life, we can't have a box with a side length of negative 8 centimeters or negative 12 centimeters, showing that this answer is wrong, and these two are the only sets of possible dimensions for the box. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing, as it shows me that you like what you see, which helps me post more videos. Anyways, that's all for now. I hope you have a wonderful day.